without losing any more time, I'm going to present you Dani. Dani is, well, Dani for friends, but Daniel Alcalá-López is got his PhD from the University Hospital of Aachen in Germany in 2018. And during that time, he also had a chance to visit some labs in the University of Pennsylvania and at Neurospin in Paris. After that, he was a postdoc at the Basque Center on Cognition, Brain and Language here in San Sebastian from 2018 till 2020. And if you had the pleasure of meeting Dani, like I did, you know that he's really, really passionate about research, and he's also really passionate about all the things that we could do better and we could improve to have like a better research and also a better make our lives better as researcher. Obviously, Open Science is one of those things. And that's why he became a fellow of the Open Science Foundation in 2020. And his talk is going to be about his work with this foundation. So please, Dani, the floor is yours, please.
Thank you, Yara. I'm going to share my screen.
Yeah.
And
I'm going to hide myself.
I think it should be fine now, is it?
Yes.
Okay, cool. Wait a second. Okay, there we go. Are we set? Cool.
Yes.
Perfect. Okay, so hi everyone, and thanks a lot, Chiara, for the introduction. It was very kind of you. Today I'm going to be talking to you about one aspect of open science that I find particularly interesting, and that is the data itself. And so I will be talking about a few things that we can do to make our data more accessible with arguably a small investment of our time. So I didn't have the time to do that yet, but I'm going to upload my slides to Zenodo because I included a lot of links with useful information in the presentation. So I will do that just right after the presentation, so you can find it and get all the information that you want, okay, from my presentation. And yeah, I said I was gonna talk about open science, open access, and open data. But before I get into the specific, I wanted to talk to you a bit about the Open Knowledge Foundation and the work they do. So the Open Knowledge Foundation is a nonprofit organization whose mission is to help create a fair, free, and open future for everyone. And they do believe that all non-personal information should be open and free for everyone to use it, to build on it, to share it. And they engage in a variety of activities to try and achieve this. From teaching data literacy to other researchers, for example, and creating and developing new tools to deal with open data and open science in general, but also campaigning and community building. So they do a lot of stuff, actually. And among the many, many things they do, one of the projects they have is called the Frictionless Data for Reproducible Research Program. And the project is funded by the Alfred Sloan Foundation. And with this project, they collaborate with researchers around the world in different ways. For example, they have the Fellows program, where they teach early career researchers like me about open science and data management practices and promote the use of the frictionless data tools. And I will talk about those tools in a minute. But they also have funding for developers to create new tools for open data and open science. And they have also something they call pilots, which are kind of like hands-on examples of things that we researchers can do to improve our data management practices. And we can think of them as use cases where the Open Knowledge Foundation and with this project helps researchers solve the problems that they may have with their data workflow. For instance, they have this really cool project with the journal eLife, where they help the journal develop a framework for everyone sharing the data from the publications on eLife. They really encourage authors to share the data. And I don't know if you have seen it, but oftentimes you find that below a figure or below a table, you actually have the data and you can play around with it. So if you didn't know about this, go check it out, because it's really cool that you can actually play with real data from real publications. And if you're interested in the Frictionless Data project, I put the link here. So I really recommend you go and check it out, because it's a very good opportunity to learn about all these things and to actually get real life hands-on experience on these type of open science tools and techniques. Along the program, they also encourage us and support us to become advocates for open science. And for instance, they encourage us to give presentations like this one that I'm giving. And yeah, it's a paid fellowship. So I really recommend you to check for next year's edition, because it's a really good opportunity. But now going back to our problem of open access and open data, I wanted to first make sure that everyone is on the same page when it comes to why I think it's important to be talking about open data. So, of course, I had to start with the everlasting cautionary tale that we live in, the replication crisis. And you probably have heard a lot about this. You might even be tired about the topic. Many of us are, in a way. But yeah, let me just say very briefly that in the end, we say replication crisis, but it turned out to be more than a crisis of replication, since we are now very aware of all the problems that we have, for example, with the reproducibility of our work, or with the robustness of the analysis pipelines that we use normally, or even with the generalizability of our results. So it's actually kind of a big crisis. And I wanted to mention specifically this piece from the Johns Hopkins Medicine magazine, due to its, let's say, current relevance, because it builds on the case of a series of publications in high impact journals, such as Science and PLOS Pathogens, warning about the presence of a virus never before seen in humans. And I mean, it's not about coronavirus, but you can guess that it's quite an important topic to be talking about. But the thing is, after a few years, journals had to retract these papers after many failed attempts to replicate the original findings. But the thing is, during all those years, many of the studies started, and some of them even were published, where they explored possible links to the virus in many infectious, immune, or even neurological and psychiatric diseases. And we're talking about research that can directly influence our health by influencing the way medical doctors diagnose or choose a treatment, which means that a sizable amount of public money was invested in a research agenda that was doomed to fail from the beginning, just because we didn't have access to the original data and we couldn't check for errors. And let me tell you, in a country where very little money is invested in scientific research, that hurts. And I'm sure everybody here knows many similar stories, so I'm not going to get too much into the details. But if anyone is interested in reading more about the topic, I recommend that you have a look at this link down below, the reproducibility curated list of resources. It's a list of resources that Brent Roberts and Dan Simmons put together, and you can find many information sources of each and every step of this crisis that we have. And given the magnitude of the problem, it only seems sensible that any attempt to solve this crisis is going to have to involve opening up our work. So that includes different aspects of the research cycle, which, let's be honest, can feel like a big burden to a researcher who already works too much and paid over time. I feel that. But, well, I'm sure you have seen this diagram before, at least since Verena Heiser mentioned it on Monday. So I won't go into the details. But roughly speaking, I think we can all probably agree on one thing, and is that at every step of the research cycle, it appears to be something going somehow wrong. And in the end, everything is crucial. All of that needs to get fixed. It's not like we could just ignore some of the aspects. But I get it. I mean, when you look at the entire thing, it sure can seem like a big uphill. And especially for early career researchers, it is definitely overwhelming to think about all the things you need to do to make your research more open. But I wanted to argue in this presentation that there are some things that you can tackle now that I believe can help a lot. And they only require a very reasonable amount of time and effort. And these things involve how we deal with and how we manage our data. And why focusing so much on data, you may wonder. We'll have another horror story for you. And it started at the beginning of this year when Kate Laskowski, an assistant professor at the University of California, Davis, had to retract one of her published papers. They had shared the data from this publication, so hats off to the team. And a colleague of them was having a look at it when they found a few problems with the raw data. So they contacted her and they asked Professor Laskowski about the errors that they found. So she went and had a look at the data herself, trying to figure out what had happened. But sadly, they failed to understand how these errors in the raw data came to happen. And so they decided that the best solution was to retract the paper, since not even themselves could trust the results anymore. So think about it. After all the time and pain spent collecting and analyzing the data, and the only conclusion we have is we cannot know. We simply don't know whether the results are good or not. And we cannot know because the management of the data wasn't good enough. And you may think, well, everyone makes mistakes. And of course, I too think that some mistakes we cannot even prevent because they just happen. But sadly, I think having poor data management practices will almost guarantee you that you will run into these mistakes. So those we could actually avoid. And this appears to be the case of Kate Laskowski and her lab, since she got a bit worried about the case, and she actually went through the data from previous published studies that they had, and they checked if they had similar errors in other studies. And that was the case. Later this year, she actually had to retract another 2 papers. And that's a lot for anybody's self-esteem, I guess, because in the end, we invest so much of our time and our life in our work that just throwing everything to the bin just because some error happened, we can't even know why, but we could actually have done something to avoid it. It's a lot. But don't get me wrong. I mean, to me, she's a wonderful researcher. I do not believe that she's not a good scientist because she made mistakes. What I do think is that we all make mistakes, but it takes a lot of courage and professional integrity to take and those mistakes and do something about that. So what I wanted to show with this was a real and recent example of how maybe changing minor things in the way we manage our data can actually have a deep impact into our work. Okay. So this is something that I'm going to show you now, that the Professor Florian Markovits, a senior researcher at the Cancer Research UK Cambridge Institute, has clearly pointed out in a very recent paper where he lists a number of reasons why you would want to make your data more open. And I actually think that Verena Heise also mentioned this on Monday, but I wanted to take the opportunity to recommend the presentation that he gave at the Riot Science Club in this link and down below, which is a seminar series on reproducible, interoperable, open and transparent research findings. That's why the name Riot comes. And yeah, I really recommend you to go and check their YouTube channel because they have a lot of amazing content on mostly open science in a weekly basis, I think. So I slightly adapted some of the selfish reasons to work reproducible from Markovits' paper to refer to open data in particular. So first, open data can save you from many disasters. And I already told you about this case that Kate Laskowski had this year. But also, this is an incredible example, and it comes from the paper, so I'm borrowing totally from the paper. Because in this editorial expression of concern at Science, they let us readers know that the data from a recent publication was basically lost forever. And the only copy that existed was in the laptop of one of the researchers, and the laptop got stolen. So that's it. The paper is already published, the work is done, but all the money, time, and effort spent collecting this data is lost forever. Nobody will be able to use it anymore. No more benefits from this effort that they did collecting this data. And I don't think that's the best use of research money that we can make, even if it's public money, especially if it's public money, but even if it's private money. And had the authors shared a copy of the data in a public repository, this could have ended in just a boring anecdote because there wouldn't be a problem. Then a second argument to share your data openly is that it actually helps you through the writing process. And this is also kind of a classic, and I borrow from the XKCD comics, but even if it's a classic, I think it's a perfect example of something that we can actually even keep on doing wrong even when we are aware of these problems. Because in the end, we have to do many things in our working days, and you always think that you will always remember what you're doing, because after all, it's something that came out of your mind, so you surely will remember, right? Until you don't. And then you will always forget about whether you transformed this or that data column, or you actually just took this data from the experiment, or whether which one is your final version of the data, if it's the final or the final or the final for real version of the data. And we will always forget about these things. We cannot keep thinking that we will remember in many years ahead, because we won't. And having a clear documented repository and using version control systems such as Git, which we already talked about during the break hack Donostia, can and will save you a lot of time wandering around all data files. And finally, another good argument for sharing your data openly is that I think at some point we're always going to have to work with somebody else's data. It's like, I don't really think I know anyone, research assistants, graduate students, postdocs, anyone who never had to work with other people's data. Maybe who actually had to take over some project that somebody abandoned after they left the lab or something. And as this comic from Dilbert mentions, it might have seemed obvious to that person what the project was about, but actually you start going into it and it's not obvious at all. It might seem that it's doing something, but it's not, and you don't really understand the parts or how they connect. So, I mean, you cannot do anything about other people's projects, but you can do about yours. And good practices in data management will protect you from other people's urges to kill whenever they need to deal with your data. Okay, so I hope by now you're convinced and you want to share your data, since it's not only great for science in general, but also good for you too. So how do you get started? In a recent publication, Brian Nosek and other researchers created kind of like a classification system to guide your way through the open science world in general. So they cover not only data, but also like scripts, analysis, pre-registration, and so on. But I'm going to be focusing on data. And regarding opening data up, they state that a bare minimum would be to actually have journals encourage people to submit the data, or in most cases, they don't even mention anything. But of course, this is not open at all. Like, this is not something we could consider a good practice. So they label this as level 0, like not even an attempt to go open. But a step forward compared to this would be to at least state in your paper that the data is available to anyone that wants to use it, but still we're going to be seeing that just doing that and allowing people to passively ask for your data, or even just linking it for to a platform that you have or something, is still not good enough, because it's actually very hard for people to find that type of data set. And even better than this would be to actually post it in a trusted repository where everyone can access it without relying on your help to find it. And even one step further from that would be that not only you do that, you need to do that, but also before publishing, it would be great if you actually reproduced your results independently. Like, you publish your data in a trusted repository, you give it to other researchers who will try to go over them and then get to the same conclusions. That would be kind of like the ideal, but we know it actually takes skills, takes time, and we might not even be able to do that all the time. And especially for early career researchers, I think we shouldn't let the perfect be the enemy of the good. And if we are talking about first steps, level 1 is still better than level 0. So today, I wanted to show you how to get to at least level 2 without that much of a hassle, okay? But before you jump and upload your data to Dropbox or Google Drive or something like that, and then share it with your followers on Twitter, I'm going to stop you there, and I'm going to ask you to think and put yourself into the shoes of the people that can potentially be interested in reusing your data. How will you find the data? Let's say a year after you publish it, because probably a tweet is not the best idea to go back and search for a tweet that was published a year ago. And hopefully your personal files in Dropbox or Google Drive are not going to be indexed in public databases. I hope so, at least. But also, how do you think other people will try to find your data? What keywords are they going to be using? I mean, if I just remember that somebody shared it somehow in some platform, it's really difficult for me to actually find that data in the future. What kind of keyword would you use to be able to find the data set? So you had to think about that. You had to put yourself in the shoes of the people that might be interested in your data, and then come up to with a strategy that you can use in those situations for them. So I also wanted you to think about these questions. Okay, you managed somehow to get the data, but did it ever happen to you that you found an interesting data set from a publication you liked, but didn't understand some of the columns or how some of the variables were coded? Also, at some point in your career, I'm very sure that you weren't sure actually whether you can use data from Excel and import it to Python, or how you do that. Or even, can you open an SPSS file in Excel? Those are things that we need to learn on the way. We all need to learn through this. And another example could be, for example, for instance, when you find a data set in Kaggle or any other data sets database, sometimes you don't find good documentation explaining everything, including, for example, to who this data belongs to. And can I actually legally reuse this data? This is something that we need to do. We need to provide people with this information, because all of this is very important for the people that need to use our data. And all of this are the things that we could call the frictions that we get when we deal with open data, okay? So this is where the Frictionless Data project comes into play. It is an open source project that involves many aspects, including specifications for data and metadata, but also a collection of software libraries. And they mainly developed these libraries in Python, but then they adapted to other programming languages. So you can find all the tools in R, Java, and so on. But it's also a set of data management best practices to kind of like go together with these tools. And all of that is to ensure the interoperability of your data. And what does that mean? Well, Lily Winfrey, the manager of the program, the Frictionless Data program, always uses this analogy of a Lego piece. And a Lego piece, it's the most interoperable thing that you can imagine, because you can grab a Lego piece from one set and use it with another set. It's that plain and simple. There is no compatibility issues between pieces from different Lego sets. You can just use them because they are designed systematically so they can work together, right? So the idea about the frictionless data tools is to work with a data package which follows the same logic as the containerization of software. You wrap up your data, for example, a CSV file, with the associated metadata and maybe a schema for the later validation of the data package. I will talk about that in a minute. And then you package it together, you wrap it in a package, and then you can use that package with any tool that you use. Do you use R for your analysis? It's fine. You're going to be able to read it because it's machine readable and it's also human readable. You use Python, you use SPSS, it doesn't really matter. You're going to be able to use this data package with any platform, any software, any tool that you want, okay? So that's kind of like the idea, to have a containerization of the data with all the relevant information that anybody could need to reuse this data, okay? But I think it's time for me to get started with a hands-on example. It's kind of late already. So I'm gonna walk you through a couple of frictionless data tools so you can later go and explore by yourself. But I think it's a good idea for me to actually show how to kind of like navigate through them. So I'm gonna stop sharing my slides and let me open in the browser. We're gonna be doing an example with real data from a colleague. Okay, so let me share. Yeah, so I have this colleague that wants to share his data, but he's not sure how to do it. So I told him, okay, maybe we can actually do it together, and I will show you that it can actually be simple and relatively easy for you to do. So I went to my GitHub and I'm going to create a new repository. Okay, since this is a demo for BrainHack, let's actually put a name that we can identify later. And the project of my colleague is about a lexical decision task. So we're going to call it LDT to remember which project we're working with. And I don't have the time to like fully fill all those fields with a description, but it's definitely a good idea to add a description, but you can do later. One important thing is that you need to make the repository public, at least at this stage, because we're going to be using a couple of tools that are going to be reading our repository to help us with a couple of things. So you need it to be public. And then I'm also going to create a README file, because that you should always do that in general. But also we're going to be using, we're going to be making good use of that. And then, okay, I have my repository right now. So I'm going to upload the data files from my colleague. And I think I have the data here. So we can just drag and drop here. One thing that I didn't mention is that all the data, the frictionless data tools are command line tools, but some of them also have user interface. So I'm going to show you the tools that I think are the most important, the data package and a tool to validate data packages. And the thing is, you can always use the command line if you feel more comfortable, and you actually have more options in the command line because they were developed in the command line, and not all of the options go directly into the user interface version. Okay, but I think for this tutorial, it's better if I just show the user interface. So I uploaded the data from the project. So I'm gonna add that to my GitHub repository. Since I'm working on this demo, I'm gonna push to main directly. But yeah, you can see now that I have my CSV file and that I can click on it to just eyeball it. I don't know if you knew, but it's actually helpful that GitHub allows you to see the data files if they are in specific shapes, but mostly a typical CSV file, you can see it. And yeah, my colleague just sent me this data file, and I have 11-ish columns, I think, and well, a whole bunch of rows. So yeah, I mean, looks good. But then if I try to go like, okay, first column is language, and I have French here, but probably we have other languages. Yeah, like Spanish here. Yeah, so we have languages, but does that mean the language of the presentation of the stimuli, or the language that the participant had to use during the experiment, or the mother tongue of the participant? Maybe all of that, maybe none of that. We actually don't know. And I need to ask him, because otherwise I just literally cannot know what this means. The second column, for example, participant, seems more obvious. It's probably a coding, an ID number for the participant. And yeah, and this third one, for example, occurrency order, it appears to be just a list of numbers. I don't know how long. Okay, they appear to be 120 numbers. And oh, they finish actually when participant 101 ends. So probably, I guess that's the number of trials that each participant goes through. But I should also ask my colleague about that. I can't really be sure about that. Then we have other columns, like this one seems to be a list of files. So I'm guessing that's the file that the presentations were used. So this would be the stimuli, I guess, and so on. You actually get the idea, right? We have a lot of information, and this is a very clean data set, and still there's a lot of missing information that I need if I want to reuse this data for my research or something. So what can we do about that if we want other people to really benefit from this data and really use it? So I'm gonna go now to one of these tools, the creator of the data packages, and I'm gonna show you how you can wrap up your data with all the meta information that anybody could need in the future to work with this data. Okay, so again, I'm gonna just drag and drop my data here. Well, my colleague's data. I'm not gonna claim the ownership of the data. And let me just drag and drop here. Oh, yeah, actually, this is this is something interesting. You can actually load data from your computer here, but if you think about it, even if I give you all the information, all the metadata, if I just share a data package that was created locally in my computer, then I need to make sure that I share the data file later on, because I might think like, okay, I did everything, but then the data file was actually in my computer. So let's do something even better than that. I'm gonna go back to my GitHub repository, and since the data is already here, you can click on raw, and then you can take the URL of this view, and this is actually the path to your data in your GitHub repository. So as you can see, I loaded this URL, and the data package creator automatically inferred that we had a data set with 11 columns, and you can just import it. And it automatically detects, for example, that the first column is full of strings, but then, for example, the second column has integers, and it is already programmed, so it will help you actually go through this, and it will do some things for you. But you can, anyway, if you need it, you can actually change it to any data format that you want. What can we do about this? For example, language. Let's pretend for a second that I asked my friend already, and I have the information that I need to give to other people so they can use my data. So for example, I happen to know that language is the presentation language. And that in this case in particular, actually, the presentation language is congruent with the participant's mother tongue. So that's information that probably people that want to reuse this data in future are going to need. Then for participant, yeah, that's a pretty simple one, participant ID. And this is maybe a bit redundant, but it doesn't hurt to add as much information as you want. I will add that it was just for anonymization purposes. And then this occurrency order, it's my friend told me that is the order of the presentation of the stimuli. And it's actually important for people to know that we included this variable because the stimuli presentation order was randomized across participants. Like all went through the same stimuli, but they didn't go at the same order through the stimuli, okay? So with this column, you can actually find the indexes of a specific stimuli and then tailor your analysis like that, okay? And we can do this to every variable that we find here. And look at here. I have this little button on the top right screen where a JSON file is being automatically created with all the information that I'm giving. You see these descriptions of the variables that I just included. So everything that I do in the user interface, I don't even need to worry about the JSON file that is going to be the machine readable file that you can use to wrap up your data, and then anybody will be able to access both the data and the metadata. That is going to be filled out for you. And of course, you can download it and customize it in the command line, for example, on your text editor as much as you want. But the data package creator is going to do most of the work for you, actually. So let's say that I don't want to go over time. So let's say that I filled out all of these fields. One thing that I should always do is to give a name to this file, and I'm going to tell you why. This was the lexical decision task, and this is the raw data. Why naming the file if actually the CSV file has a name? The thing is, within a data package, you can actually have different resources. So for example, this is not my case or the case of my colleague, but we could have, for example, another table with data from another source, for example. Or maybe we have another table with the summary statistics of these variables. And we also want to share that. So we could just go here down below and then add a second resource, like, for example, the summary stats. And then we could have as many resources as we have all together in one package, one data package, okay? That would be the same, that would follow the same logic. We would just upload a data file, ideally from a URL instead of locally. And then to give the metadata about the whole package, because this is, for example, the metadata of the first resource that we gave about the first table that we gave. If we have different resources, it's important that we also kind of give the information about the overall project, the overall package, okay? So we can, for example, give a name to the project. So I know that this was a cross-linguistic lexical decision task. So that could be our name, for example, and then the human readable version of the title would be something like, I don't know, like something more elaborated, you know? It could be, for example, I have it here. I have in my notes, cross-linguistic lexical decision task. And then there are many, like there are different data packages types that you can do when they are tabular data. It's actually that simple as I showed you, but it could be many things. For example, let's say that you're working on a deep learning model that recognizes images and so on, you know the drill. Then you can actually create like a data package, not a tabular data package that is going to be able to add many different sources of information, okay? But if it's just tabular data, it's going to be easier for you to do it in the tabular data package. And for example, they also have this other fiscal data package, which is kind of like an extension of the tabular data package that is specific for fiscal data, and it has like tailored function to it. Then we should definitely add a description of the project where, for example, you can add like a very short description of the aim of the project, of the task, of the results, as you wish. And for example, if you want to publish your paper as a preprint, it could be a good idea to link to the preprint. Or if you created a web page to share the results of your project, there's also space for it. And since this is the first time that I'm packaging this data, I'm going to put it version 1.0, but you could actually use this as you wish. And then I'm going to put my colleague as author of this. I mean, I can put myself as well, since I helped a bit. And then something very important, you should always provide a license so people understand whether they can actually legally use your data or not. So here you have a pre-populated list of possible licenses, but actually you could just type something and add any other license that you want. But let's say that we're interested in like Creative Commons type of license. And by the way, if you're not very sure about what that means, they also provide a link with a description of that license in particular. So for example, if you go down below to the metadata in the JSON file, oopsie, you see here, sorry about that. Well, I deleted that, but that doesn't matter. You can actually, in the JSON file, access the URL. Okay, let's choose a license. Yeah, here. And then just, for example, copy paste it and see the documentation that the Open Knowledge Foundation has on this license in particular. Okay, so if you're not sure, you can definitely have a look and see, okay, so for example, with this one, people can share it and copy and use it, and they can actually make any modifications to it, even if it's commercial. You just ask people to give attribution to the source and say, we made this and we use this data from this GitHub repository, okay? So one last thing that I wanted to show you is that you can not only create these data packages with different resources, you can also validate them. So for example, you can use the metadata that you created in the data package description to validate the information that should be on your data frame, just in case you accidentally delete a column, for example, when manipulating the data. But also there is a tool that actually gives you automatic testing of some properties of the table. Let's say that tool is called the Good Tables. And for that, you can actually log in with your GitHub account. And then you can say, okay, I have these repositories in my GitHub account. Let's refresh in case it isn't there. But the one that is that we're using is here, so I can add it. So the Good Tables app will have a look at it for me. If I go to jobs, oh, it finished already. So I can have a look at it and say, oh, the data is actually correct. There's no errors in my data. But actually, I wanted to mess a bit with the data very quickly so you can see what happens when there's actually an error. So for example, if I go back to the data and I just randomly add a invalid, like an invalid column here, an extra column, or I just take this line, for example, and duplicate it, I will push this with data and just do it in a branch. So I mean, I could just do it in master here, but it's fine. Okay, so I just do my pull request. And look, the continuous integration of Good Tables is already showing you that there's an error on your table. Okay, so if you click on the things, it's going to tell you like, okay, you added this. And if you go back to the details of the error, it's going to tell you, look, you added this extra value in one row, which has no column name, no other information. And also you have a duplicate row here. So it tells you, it gives you feedback on the exact error that you committed. And it tells you actually also like a few tips on how to solve it. In case, for example, that it's not an error, but some weird property of your data, you can customize a good table so it won't show you an error message. But in general, it's really cool that it gives you a real feedback to very quickly identify what the error is, okay? So for example, if I close the pull request because I obviously don't want to mess with the data, and I go back here, one thing that I wanted to show you is that it's valid again, and you can actually show everyone that your data is valid by putting your own badge here. Added good tables badge. So now everyone knows that you actually took the time. Oh, it's actually still giving me the output from the previous version, but it updates. And if you, for example, now update the data set with more data that you collected, it's going to do this continuous testing for you, these continuous integration tests. And it's always going to be kind of like a red flag, literally, on things that you should be looking at, so you don't mess too much with your data and everybody can reuse it and make good use of it. Okay, so I think it's about time for me to finish.